Hello, friends. Let us consider one topic of conditional probability. Now, basically, what we consider the probability of an event is like this. So, probability of any event A, but then we have the sample space S. Now, if suppose some event already occurred, say some event B already occurred, and after occurring of the event B, we would like to find out the probability of, say, event A, like this, P of A. But then already B has occurred. So we say like this, P of A given B. Then it is called the conditional probability. So here the sample space changes. The sample space become the elements of B. So that is the conditional probability. So for particular event A, we use the P of A to represent the probability assigned to A. Now we think of a P of A as the probability, conditional probability, but there we consider this whole sample spaces. Now suppose some event B has already occurred, then it affects the probability of A. Here very good example is given, like some blood test is done. So that event B is already occurred. And now we would like to find out the probability that certain disease be there or not. So once the blood test already done, so then the probability of having some disease will definitely change than the probability without having the blood test. So we represent like this, P of A given B, and that is called the conditional probability. So let us have one simple example, like complex components are assembled in a plant that uses two different assembly lines, A and A dash. Line A uses older equipment than A dash, so it's somewhat slower and less reliable. Suppose on a given day, line A has assembled 8 components, of which 2 have been identified as defective and 6 as non-defective, whereas ADES has produced 1 defective and 9 non-defective. So we write all this data in one table, like line A, 2 defective, 6 non-defective, line ADES, 1 defective and 9 non-defective. So all in all, how many total components are there? So 6 plus 2, 8, plus 1, 9, and 9. So total 18 components are there, where A has produced 2 defective and A has produced 1 defective. Now we select one component among these 18 components. Then what is the probability of line A component selected? Now, total components are 18. So P of A equal to number of total favorable, that is 18. And numerator is favorable for the line A component. So A component, how many selected? It is 2 and 6. So total 8 selected. So P of A is 8 by 18. So this is very simple probability. But now let us see, however, if the chosen component turns out to be defective. So now we have already completed the event A. However, if the chosen component turns out to be defective, Then the event B has occurred. Defective. How many defectives are there? Total defectives are 3. 2 produced by A and 1 produced by A dash. Since these 3 components are equally likely among themselves after B has occurred, B has occurred. So suppose first B has completed, that is the defective items. So now the sample space becomes 3. What is the probability that line A? So now it is nothing but total 3 defective and line A has produced 2. That probability is 2 by. So basically this formula is used. P of A given B is P of A intersection B over P of B. We take one more example. Suppose that of all individuals buying a certain digital camera, 60% include an optional memory card in their purchase, 40% include an extra battery, and 30% include both. Given that the selected individual purchased an extra battery, the probability that an optional card was also purchased. Now let us give the event A name, event A as optional card. Now 60% include an optional memory card. So P of A is 0.6. 40% extra battery. So let us write B as extra battery. So P of B is 0.4. 30% both. That means P of A intersection B is 0. Now let us see. Given that the selected individual purchased an extra battery, so that B already occurred. Find the probability that an optional card was also selected. Optional card is A. So find the probability like this, A given. And that is nothing but the formula used, P of A intersection B over P of B, that is 0.3 over 0.4. So that is the 0.75 is the answer. Now, there is one theorem on total probability. It says like this. Suppose that events E1, E2, En are mutually exclusive and exhaustive. So suppose say that you have like some event, say suppose E1, say E2, E3 kind of things. Then for any arbitrary event A, suppose we have event A here. And if you would like to find out the probability of event A, then it is like this. P of A equal to first P of E1 into P of A given E1. So A part in E1. Same way plus P of E2 plus into P of A given E2 and so on. P of E3 into P of A given E3 and so on. So this is known as the theorem on total probability. So basically this theorem is the extension of the our conditional probability. So conditional probability P of A given B equal to P of A intersection B over P of B. So P of A intersection B equal to P of B into P of A given B. But now this is the extension. If there are more than 2, 3, 4, 5 events, then we have like this. We take one example. An individual has 3 different email accounts. Most of her messages, in fact, 70% come into account 1, whereas 20% come into account 2, and the remaining 10% into account 3. So we have 3 different things. So we can write P of E1.7, then P of E2. We write so E2, 20%, so that is 0.2, okay? And so on. P of E3 is 10% into account 3, so you can have P of E3 is 10%. And all the data we have, 1% spam of these messages, account 1% spam. So we write, suppose say A is the email in spam. So we have P of A spam, but it is from first one. So 1%. So that is 0.01, like this. Then 2% spam from 2, 5% from 3, and so on. The question is, what is the probability that randomly selected message is a spam? So basically, we have like this. So A, we write the message is spam. EI is the messages from account I1 to 3. Data is given P of A 0.7, P of E 2.2, P of E 3.1. Now P of A given even 1% spam from first one, that means 0.01, 2% from second one, and 5% from the third one. Here it is 5% from the third one. Now we would like to find out the P of A. So we use the multiplication rule. This rule we use total probability. And so that is the thing, but P of E1 into P of A given E1 plus P of E2, P of A given E2 plus P of E3 into P of A given E3. This is 0.7 multiply 0.01 plus 0.2 multiply 0.02, 0.1 multiply 0.05, and find out the value. So this is 0.016. So that means around 1.6% mails are spam. Thank you.